Today we're going to be demonstrating data access in C# using EntityFramework in .NET 6. In advance of today's exercise, you'll want to install .NET 6.0, Visual Studio Code or whatever IDE you want to use, and Docker Desktop. EntityFramework offers a database-first as well as a code-first approach, typically. For today's exercise, we're going to go database first, and that means we'll have a database already existing with a schema that we'll leverage for scaffolding out a data access layer. In order to grab that, we'll start with this wiki toxicity database that's based off of Wikipedia's detox project. So we'll just pull down this repository, we'll Docker compose up, and then we'll have a running instance of Postgres to work with. I've pulled down our database repository. I'm just going to cd into it. Here I am. I'll Docker compose up, and I can do that as a -d. That's detached, so I don't have to see it running. But you'll note here we've got Postgres, pgadmin, flyway. Postgres can be a database. pgadmin allows us a visibility, a UI into it for checking that it works or fetching specific data. And flyway is just going to migrate that Postgres database up to the current schema with any data that we want to put in it. So that looks like it's ready to go. You'll want to install the .NET Entity Framework tools. I've got mine installed already, so this is the error message I'm getting when I try to install it, but this is the line that you'll run for that, .NET tool install global .NET EF. After that, we're ready to generate some code. So I've got our directory for today's exercise. I'm just going to do a .NET new WebAPI, and that'll get us some code that we can use to play with, and we'll open that up in Visual Studio Code. We'll want to be able to connect to the database, so I've gone ahead and done .NET user secrets in net here, and I'll also set connection string specific for the Docker container that we pulled down. And that now has set a connection string specifically for that toxicity database we ran. We've configured our local environment to be able to connect to our Postgres instance. That was the user secrets bit. Now we need to add some dependencies so that we can generate EntityFramework code and connect to a Postgres instance via EntityFramework. We can do that with a .NET add command. So we'll add a couple packages. .NET add, I'm going to reference my csproj file here, which is net6 ef csproj. We'll add package Microsoft EntityFramework Core design. We'll also need to add a package for Postgres. So that is npg-sql EntityFramework Core. And .postgres. And voila, we have that guy added. I think next we can scaffold. This command's a little bit longer, but .NET EF DB context scaffold is the base of it. From there, we're doing the connection string for the database. That's how we're going to be able to connect. The means by which we'll connect, so npg-sql, that's the dependency we just added. And then output directory is optional, but I prefer my stuff to go in infrastructure for repositories or data access stuff. So I'm going to output to infrastructure. It's generated, which is great. We should take a look at it. Let's hop in here. Infrastructure now exists, and it has Flyway schema history, which tracks, it's just an entity that represents the Flyway migration notes that Flyway just injects of like, what happened? What version are we on? Toxicity annotation is going to be our main entity. And so this is just what the schema of the database looks like for the toxicity annotation table. And toxicity context, this is sort of the main powerhouse of the EF. We're going to configure our startup to just have this guy configured, ready to go. But you'll note, because I didn't use a no on configuring argument when we generated the EF, we should have done that. We could have put no on configuring here. Since we didn't do that, we got this, which is just plain text, our connection string. I prefer not to have that. It's nice for like easy startup if you don't want to configure your connection string in user secrets, but since we did that, we're going to rip that out. No big deal. We'll know better next time. Next, we'll go ahead and configure and set up dependency injection for EF. All right. Let's get started. So I'm going to grab the connection string. So I'll create a variable, which will be builder.configuration. We're going to grab a section, the connection string, which will be toxicity DB. That's what we configured it to be earlier when we did the .NET user settings or user secrets thing. All right. Now that it's happy with me and we have a happy string, we can go ahead and do builder, services, add DB context. And this is where we're going to add in our toxicity context. It's going to be like, hey, you don't have our user space ready to go. There you go. We know what we're using. We're using some infrastructure. And then we'll do some options, and we'll say, hey, use NPG-SQL. I didn't mean to do that. Say, hey, use NPG-SQL. And again, it's going to say, hey, I don't know this specific using declaration, which will be fine. And we'll pass in our connection string. Great. Awesome. So now we have dependency injection for toxicity context. But we've got to use it. So let's find a way to use it. All right, this template was generated with controllers, but I don't really want to use controllers, so I'm going to go ahead and rip some stuff out. This weather forecast, controllers, gone. No more controllers. I'm just going to directly map a get. We'll do that by also removing the add controllers stuff. We'll add the endpoint explorer. We'll drag Swagger out so it's not just in development. And we can get rid of the use authorization and the map controllers. Now we can add a map get. All right, let's add a map get. App.map get. And that's just going to take a route as a string and a request delegate, which is just a delegate with a HTTP context. So we'll do that as /toxicity. And then for our request delegate, we'll do an async delegate here with our toxicity DB context goodness. And then we will go ahead and throw in some code. Maybe we'll just return a whole list. So DB context has all sorts of cool stuff on it, but toxicity annotations is the entity we care about. And we'll do a to-list async. And of course, we should await our asyncness. All right. So now we've got toxicity mapped to awaiting an entire list from this database, which is probably crazy. We should probably have like skips and takes, do paging, filtering of some kind. But in our very stripped down version of OData, we're not going to do any of that. We'll just do a .NET run and we'll see it. All right, we're building, we're running, we're going to it. And we have a /toxicity endpoint, so we'll go to that. I'm doing it via the web browser because I think there's like 150,000 results, and Swagger would reasonably yell at us for that if we tried to demonstrate all of that, render all of that in Swagger. But yeah, looks like we're getting results from a database. It's a lot, which is reasonable. Awesome. Now we've only created a get. In standard CRUD operations, CRUD stands for create, read, update, and delete. We have what I like to refer to as pirate CRUD because we only have the R. I think we should get some more CRUD done. So let's do a post and a put. Start with a post. A post is generally a create. So anything we do will be creating via this endpoint. So let's we can actually start just by copying this code down here, change it to a post. We still have our request delegate here, but we will add to it a body, which is a toxicity annotation. We'll just call that input. Now instead of to-list async, we'll just do an add async. And we'll add that input. We're just going to implicitly trust that it's not bad. We don't need to return that. We do also need to await save changes. So for most modifications of the database, where the state of the database will change, we'll need to close the transaction through save changes here. And then we will return input. There's all sorts of things here that can throw exceptions. We're not going to worry about that for the purpose of today's exercise, but I'll include in the documentation links below the links to commonly thrown exceptions, and we can work through those in another video if people are interested. Let's keep going, turning out some endpoints here, and then we'll, at the end, go back to Swagger and start playing with things. The next one is a map put. Now, put is typically like an idempotent save, which is to say it knows if the entity exists and will react appropriately. If you do the same action multiple times, it shouldn't change the state. I'm not going to be too strict on that, but I am going to make it a put that is an update and an add in that sense. So the first thing we're going to want to do is we're going to check if we can find it. So let's find our input. That will be our entity, await, and we'll go to the DB context, toxicity stuff. We'll find async. The primary key on this is rev ID worker ID, so we'll go to that. So now with that primary key, it should be able to see, hey, is there an entity in the database? If it can't find it, and you'll see right here in the docs, if you can't find the entity, then null is returned. So we can check if entity is equal to null, then we'll do an add workflow. That is to say that there's nothing to update. So we're just gonna add, and that matches what we would kind of expect there. And then we would return the input as well. We would return that entity. Why not? The next thing would be if we have a response, then we should go to that entry for that entity, and we should change the current values to the values of input. And once again, we should save changes async there. And then we can return the input. So now we should expect that this will be updating. And in fact, we can do a console write line here just to prove to ourselves that we're doing an update versus an add. This isn't necessary, but just for, it'll be a Q console. That's how my fingers decided to work today. So that's the add versus the update. That'll be great. The last step is the delete. So that'll complete our CRUD of sorts. We can do we'll just use the code from up here, and we'll map it to a delete. So now we know we'll have a delete workflow. We'll want the primary key for this. So instead of input as a body, we'll take decimal rev ID and decimal worker ID. That's once again the primary key there. And we can do a find async like we did up here to find our entity if it exists. And I think we'll do like if the entity doesn't exist, then we would just return false. If it does exist and we remove it without exception, then we'll return true. I think that'll work. So then here we can do that if entity is equal to null. Then we can just say like, well, there was nothing to delete, so although we'll return a 400 or a 200 instead of a 400, we can just be like, yeah, no, there wasn't anything there. But if it does find something, then we can do the remove method here against that entity, and then it'll just be removed. And we can just save changes to state and return true. There was something to remove, we removed it. And that's a delete. Now that we've done all of this, we've got our get, post, put, and delete, we can go ahead and play in Swagger. Let's do that next. All right, I did a .NET run. I think we're ready. Let's go to Swagger. And you'll note we have get, post, put, delete. That's great. We could add a get specific ID, but I think for today, it's just a matter of you do sort of the delete workflow with the get, and then you use the primary key to do a get specific. For a post, we know this will always be a create. So if we execute this, great, we've got it. Let's change that. Once again, getting a response that's successful. And we can in fact delete that as well, right? So if we do 0 and 2, we know we just created that. We should return a true. If we do that again, we get a false. That's because it's not in there anymore, right? Delete the other thing we created, great. Let's keep 0, 2 in there, and we'll do a put. So we want to update. We want to say, hey, 0, 2 actually has a toxicity of 5. Super toxic. Oh my goodness. And you'll note it updated that. and we can do it again, right? If we go back over here, we know update, right? But if we wanted to change it so that 0, 0 is in fact a 5, we've got that result, and it didn't add, which is great. So we know that we have some CRUD endpoints working against a database, right? So this is actually altering data in our Postgres instance that we ran earlier. Today we went through the process of spinning up a brand new database instance in Postgres, have all of its schema brought up to speed through a flyway migration, scaffolded our new application that we created for EntityFramework to be able to interact with that database. We played with some secret management stuff, and we created a series of create, read, update, and delete endpoints to be able to interact directly with that database through HTTP. If you have any additional time, you want to learn a little bit more, I'll include links for the .NET 6 Preview 7 update announcement. And I'll also include the Save Changes Async documentation link. You can look through some commonly returned exceptions there and play around with try-catch operations specifically for that workflow. If you don't want to do that, well, congrats on a non-zero day.